All right, now let's solve question number 6. Let's see what it says. A particle is projected vertically upwards from a point A with speed 24 meters per second. Okay, so this is a question about kinematics and it's motion under gravity. The point A is 2.5 meters vertically above the point B. The point B lies on horizontal ground. The particle moves freely under gravity until it hits the ground B with speed v meters per second. Okay, why is this speed important? We'll talk about that in a minute. After hitting the ground, the particle does not rebound. That means it stays on the ground. That's it. Find the value of v. Okay. So in questions like these, it's always a good idea to make a rough sketch. To make a rough sketch so that you have a better perspective as to where the ground is, where the particle is, where are all the points that the question has mentioned, where do they happen to be. So the point B is basically on the horizontal ground. So let's say this is point B, okay. However, the particle is not projected from the ground. The particle is projected vertically upwards from a point A, which is 2.5 meters above B. So that means the particle is projected from somewhere over here. Okay, and the speed at which the particle is projected is 24. So we're going to take that to be the initial velocity, 24 meters per second. And these 2 points, according to the question, happen to be 2.5 meters apart. So 2.5 meters. Okay. Now, whenever you have, and by the way, before we actually dive into the question, so let's look at the motion of the particle. So we know that the particle will go up, reach its maximum height, and then it will come back down. So what we have to do is we have to find out the velocity with which it hits the ground. Okay, so now the motion will happen in a vertical line. Okay, it's not going to be symmetrical, it's going to happen vertically. Reason why we draw it like this is so that it's easy for us to understand. Okay, so the particle goes up, turns, and then comes back down, and this will all happen in a straight line. Okay, so whenever you have an object that's moving in multiple direction, what's important is to decide which side it is that you're going to take positive. Okay, so what we're going to do is we're going to take the upwards motion as positive. So if you're taking the upwards motion as positive, okay, so that means the point B, the displacement of point B from point A is now minus 2.5. Why? Because this is on the opposite side to which the particle is traveling. Okay, so if the particle is moving away from the starting point, okay, in the upwards direction, the displacement will increase. If it's coming towards the starting point, the displacement will decrease. But if it moves in a direction that is in the opposite direction compared to which the particle was projected, that means the displacement will be negative. Okay, so displacement from the starting point was now minus 2.5. Now the initial velocity is minus 24 meters per second. Okay, acceleration due to gravity, irrespective of what motion you take as positive, whether it's upwards or downwards, but if the particle is moving upwards, that means the acceleration due to gravity will be negative. Okay, the object will decelerate as it will, as if you throw any object up in the air, you know that it's going to decelerate. Okay, it will at some point slow down, it will keep slowing down, at some point it will be stationary, and then it will come back down. So the acceleration due to gravity is minus 9.8 meter per second squared, and then the final velocity will actually be equal to minus v meter per second. Okay, now although this minus word sign will eventually become irrelevant, but just for your understanding, because we have taken the upward as positive, so that means the final velocity will be negative, but we will take it as positive. Why? Because the question has asked us to give the speed. Okay, now the formula that we're going to use will be 2gs is equals to v square minus u square. Okay, and now you can see why the minus sign is kind of irrelevant. So 2 into minus 9.8 into minus 2.5 is equals to v square minus 24 squared. Okay, I don't know why I took this as minus, this is going to be positive 24. So 24 squared. Okay, now let's work this out. So what you will have once you work this out, 2 into minus 9.8 into 2.5 plus 24 squared, you will have the value of v squared, which is equal to 625. And then when you work out the value of v, that's going to be equal to 25 meter per second. And there you go. That's the answer to the first part. The question asked us for speed, and that's the answer. Now let's have a look at part B. Part B says find the time taken for the particle to reach B. Now what is B? B is basically the ground. So we need to find out the time that it takes to reach the ground. Now when it reaches the ground, we just saw the displacement is equals to minus 2.5 because it is 2.5 meters away from the starting point in the opposite direction to which it was initially projected. Okay, the initial velocity we have is 24 meters per second. We have the acceleration due to gravity, that's once again minus 9.8 meter per second square. However, the difference is that now we're supposed to find out t. So what's the best equation that we can use over here? The best equation that we can use is s is equals to ut plus half at square. Now obviously a is going to be negative, so it will eventually become minus half at square. So we'll figure that out shortly. So minus 2.5 is equals to 24t minus 1 upon 2 into 9.8 into t square. Okay, now we're going to simplify and we're going to write this nicely. So when you do that, this is what you end up with. 4.9 t square minus 24t minus 2.5 is equals to 0. Now you can multiply the entire equation by 10 to get rid of the decimal and then do middle term breaking, but I wouldn't recommend that because that will make things, that'll make life very difficult. So instead, let's use the quadratic formula. So if we use the quadratic formula, t would be equal to minus b, so minus 24 plus minus square root of b square, that means minus 24 squared minus 4 into 4.9 into minus 2.5. Now we close the bracket and we divide it by 2a. 2a means 2 times 4.9. Now when you work this out, okay, obviously use your calculator over here, you'll get two different answers. One value would be equal to 5 and the other value would be t is equals to minus 5 upon 49. Now obviously we're talking about time here. Time we know can never be negative, time is always positive. So the answer that we're going to take is the positive answer, and that is 5. Okay, so that's the answer to part B. Now let's read what part C says and solve it. Part C says the point C is 10 meters vertically above A. Find the length of time for which the particle is above C. Okay, so once again, it's very important that we visualize this. We make a rough sketch. I can never emphasize on that enough. So the situation that we're in looks something like this. So here's the horizontal ground. That is where point B is at. Okay, then 2.5 meters above the horizontal ground, there's A. 2.5 meters, and then as you project the particle from here, there is a point C which is 10 meters above point A. Okay, it's vertically above point A, not vertically above the ground, it's vertically above point A. Now let's understand, let's track the motion of the particle. So here's the ball, it's projected vertically upwards, it's going to go up, 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 it's going to reach its maximum height. Okay, and then it's going to come back down, 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 and then eventually hit the ground. Now notice that there will be, okay, so this is where point C is at. Okay, so there will be a time where the ball is above point C. Okay, so that is as soon as it crosses C, as soon as it's more than 10 meters above the ground, above point A on the way up, and then as long as it is more than 10 meters above A on the way down. So during this time, the ball will be above C. Okay, so during this time, the ball will be above C. Once on the way up and then on the way down. So both these times, the ball will be above the point C. That's above point A. That is very important to understand. Sorry, above point C. Yeah, above point C, not point A. So once again, let me explain this again because I know this can be a bit tricky. So this is the trajectory of the ball. Okay, or remember this all will happen vertically. So this is where point C is at. Now the ball will be above point C on the way up. Then once it reaches its maximum height, it will come back down. And then also it will be above point C for as long as it is not 10 meters above A. Why? Because point C is 10 meters above A. So even on the way down, for as long as the ball is more than 10 meters above A, it's above the point C. What we need to find out is what is the duration. We need to find out what is the duration for which the ball is above the point C. Okay, now, since A is the starting point, what would be the displacement from A to C? That would be equal to 10 meters. Okay, so if I can find out the exact time when the ball is at C on the way up and when the ball is at C on the way down. Okay, so hypothetically speaking, let's say At t is equals to 5 seconds, the ball is at point C on the way up, and then at t is equals to, okay, these are just random values. At t is equals to 8 seconds, the ball is once again at point C, but this time on the way down. So that means the ball was above point C for a total of 3 seconds. Okay, so what our objective right now is to find out the 2 times when the ball was above point C. Okay, once we have those 2 values of t, we will subtract them. So we know that in order to reach point C, the displacement is 10 meters, okay, which is equal to the initial velocity, let's write that down, 24, okay, and acceleration due to gravity, that's minus 9.8. So the equation that we're going to use is S is equals to ut plus half at square once again. Okay, so 10 is equals to ut, that means 24t plus 1 upon 2 into minus 9.8 t square. So what does this boil down to? This boils down to 4.9 t square plus, no, actually minus 24t, because we shift all the terms to the left hand side, plus 10 is equals to 0. So kind of a similar equation compared to the previous one. Okay. Now once again we're going to solve this, and we're going to solve this using a quadratic formula. So this time you will notice something interesting. This time when we solve this using a quadratic formula, we will get 2 perfectly legitimate values of t, meaning that we will get 2 positive values of t. So let's write the formula down. So minus b plus minus b square, so that's minus 24 squared minus 4 into a into c divided by 2a. Okay, now I'm going to solve this, and I'm going to write down the 2 values of t that we get, and then we will think about how to make sense of those 2 values. So the 2 values that we get is, one is 4.438, obviously not the final answer, okay, and the other value of t that we get is 0.4598. Reason why I'm taking so many decimal places, because it's not the final answer. Now how do we make sense of these values? Well, here's the deal. Notice that one value is smaller than the other. What does that mean? That means as soon as the ball was projected, it was at point C at 0.4598 seconds, okay, on the way up, and then once again it was at point C at 4.438 seconds on the way down. Okay, so that means if I want to find out the total time for which the ball was above point C, what I need to do is I need to subtract the 2. Okay, so I'm going to call this T2, I'm going to call this T1. So T2 minus T1, let's see what do we get. So 4.438 minus 0.4598, that's equal to 3.9782. Okay, or let's see if the question has a specific requirement as to correct to the nearest or something. No, it doesn't. So that means the ball was, let's round it off correct to 3 significant figures, a total of 3.98 seconds above the point C. Okay, so remember, the key to solving questions like these correctly is visualization. If you're not paying attention, if you're taking the visualization part lightly, I don't think you'll be able to solve questions like these correctly. So spend some time trying to visualize the trajectory before you start solving it. Okay, now let's have a look at part D, which I believe is a graph related question. Yeah, so it says sketch a speed time graph for the motion of the particle from projection to the instant that it reaches B. No further calculations are required. Okay, so that means there's probably no value of t that we have to find out, and there's no value of t that we're supposed to find out. Okay, so we know that the ball was projected vertically above from the ground at a speed of 24 meters per second. Okay, so here we are at a speed of 24 meters per second. Okay, now, and remember, this is a speed time graph, not a velocity time graph, it's a speed time graph. Now, the ball, as soon as it's projected, it starts to decelerate. So that means the speed will start to decrease, and it will continue to decrease when it reaches its maximum height where the speed is 0. Okay, make sure to label your graph. This is speed in meters per second, and this is time in seconds. Okay, now what happens after that? After that, what happens is that the ball changes direction, and then the speed starts to increase. Although in velocity terms it would be negative, but we're talking about speed time graph. So now it reaches its maximum height. At this point it's reached its maximum height, the speed is 0, and as soon as it turns, the speed starts to increase, and it continues to increase. When it reaches 5 seconds, it hits the ground, and the speed at that point is equal to what? Is equal to 25. Okay, and what's the time? At what time does it hit the ground? I think we worked that also. Yeah, so it takes 5 seconds to hit the ground, and the speed at which it hits the ground is 25. So that means this is 5, and this right here is, whoops, this right here is 25. There you go. That's it. Speed time graph done. And with that, we are done with question number 6 as well. Now let's move to the next question and see what it says.